Greetings, hello, welcome. Let's look at slanted asymptotes of rational functions. Okay, I have here a couple of examples with me. So let's dive in to sketching these problems or these functions. Okay, and the first thing we need to look at when we are sketching is the location of our vertical asymptote. Okay, the location of the vertical asymptote, which is located at the zeros of the denominator. So to get that, we equate the denominator to 0. And that gives us x is equals to minus 1 as the location of the vertical asymptote. Okay, let's look at the horizontal asymptote a bit. Question: does this graph have a horizontal asymptote? Well, to answer that question, we look at our function, which I called a graph by mistake, but we can graph this function, then once graphed it becomes a graph. But looking at the graph, looking at the function, looking at this function, we see that the numerator is of a higher degree compared to the denominator, and the numerator's degree is 2 and the denominator is 1. So whenever you have such a case whereby the numerator is 1 degree or a degree higher than that of the denominator, then it means the graph does not have horizontal asymptotes. Okay, so does not have horizontal asymptotes. So it means we do have slant asymptote or oblique asymptote. Now to find the location of the oblique or slant asymptote, we need to perform long division on our on the rational function. So we need to perform long division. So it's the numerator divided by the denominator. So x squared minus x plus 0, x plus 1. Okay, I'm just adding a 0 there. If you don't want to add it, you can leave it out. Okay, so go on, x squared divided by x. So x squared divided by x gives me x. So x multiplied by this x gives me x squared. Just putting a minus there. X multiplied by 1. Oh, that's positive. X. Alright. So this x minus x squared gives me 0. Minus x gives me minus 2x plus 0. Minus 2x divided by x gives me minus 2 So minus 2. Minus 2 multiplied by that x gives me minus 2x. Minus 2 multiplied by 1 gives me minus 2. Therefore, subtract these ones from this. Would say minus 2x minus minus, that means minus 2x plus 2x gives me 0. Minus and minus becomes positive, so minus 2x plus 2x is 0. 0 minus minus 2, that is 0. 0 minus 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 2 is the same thing as 0 plus 2 equals to 2. So positive 2 is the answer. Alright, so we have a remainder. Therefore, we can rewrite our rational function as x minus 2 plus 2 over x plus 1. If you multiply this, if you add this out, it will give you exactly the answer you have. It will give you this. It should give you this. It should give you exactly that. Okay, so what did we do? Using long division, we brought that down. Now, the answer to your long division, the answer you get, this answer, that is your equation for slant asymptote. That's the location of our slanted asymptote. So change the color. So slanted asymptote is located at y is equals to x minus 2. Alright, so we just plot this equation to get our slanted asymptote, and then you will have it once you plot this line. That's the location. Slanted asymptote, equation of a straight line. Okay, let me just get the y-intercept and x-intercept of the slanted asymptote equation right here. Would say x-intercept y is 0, so 0 is equals to x minus 2, therefore x is equals to 2, therefore x is 2, and y is 0. Y-intercept of a slanted asymptote, when x is 0, y is minus 2. Cool. Okay, now let's get the x-intercept for the rational function. X-intercept when y is 0, what is the function? When y is 0, it's x squared minus x over x plus 1. What is x when y is 0? 0 is equals to x squared minus x equals to x minus 1, x minus 1. Therefore, found that x is equals to 0 and x is equals to 1. So x is equals to 1 or x is equals to 0. So there are two values of x. Okay, let's look at the y-intercept, the rational function when x is 0. So y is equals to 0 squared minus 0 divided by x, or 0 plus 1. So 0 minus 0, that's 0 over 1, that's 0. So 0, 0, x-intercept. With this, we can plot this equation, this graph. Plot, I mean sketch. Can sketch it now. Okay. I should think I would be better now, but okay. So we have vertical asymptote at x is equals to minus 1. There's vertical asymptotes. X is minus 1. Minus 1. Okay, what else? Vertical asymptote that's at minus 1. No horizontal asymptote. We have instead slanted asymptote at y is equals to x minus 1. So I'm going to plot this equation for slanted asymptote, which is y is equals to x minus 2. Y is equals to x minus 2. Okay, we already have the x-intercept and the y-intercept for that. X-intercept is what? Is at 2, 0. 2, 0. X is 2, y is 0. So x is 2. X is 2 when y is 0. And we have the y-intercept. X is 0 when y is minus 2. So this tells us that the straight line graph passes through these points. So the asymptote, this is our slanted asymptote, which is at y is equals to x minus 2. Question now is, where lies our graph? That's the question. Where lies our graph? Is it in this region? Is it in that region? Or that region? So that's what we need to find out. Let's look at x-intercept for the rational function. X-intercept, we have 1 and 0, 0. the graph intersects the x-intercept, the x-axis at 1. At 1, okay? Use a different color. At 1 and at 0, 0. Okay. Find out what is the value here at minus 0.5. Minus 0.5. Minus 1 over 2 plus minus 2. Minus 2 plus 2 over minus 1 over 2. Now let me use, this is also fine, plus 1 plus 1, so this is 2 minus 1 minus 4 is 2 over minus 1 plus 2 over 2 minus 5 over 2 plus 2 over 1 over 2. This was minus 5 over 2 plus 2 multiplied by 2 over 1. Okay, this gives me minus 5 over 2 plus 4 minus 5 plus 4 times 2 is 8. So 5 minus, so this is 3 over 2. 5, 6, 7, 8. So yeah, 3 over 2. 3 over 2, that's 1.5. 1.5. So say 1.5. There we go. So now we have an idea of the direction of our graph. Now I can just roughly sketch it. Okay, have one in that, have one there, and then it should be one in the region below. Okay, let me make sure, let's find out. Okay, so when x is minus 2, what is the graph? Minus 2. What is y? Okay, let's just do that. Minus 2, minus 2, minus 2, plus 2 over minus 2 plus 1 minus 4 plus 2 over minus 1 minus 4 minus 2 minus 6. So when x is minus 2, y is minus 6. Minus 6. So it's in this region. I need to find out also what is this intercept. What is the intercept between x is equals to minus? Yeah, what is the value of y when x is minus 1 in the slant equation or in the linear equation? In this equation, x minus 2. So if x is minus 1, minus 3, y is minus 3. Therefore, this is correct. Okay. So the graph will be in this region. It will approach the asymptote. As the asymptote approaches infinity. So this is how this graph will look like. The graph of the rational function of so to look something like this. Okay. So yeah, now okay, so guess that's it for this video.